convolutions will we be doing over here?
Eight.
We applied 8 to each one of these.
So the 8 into 6.
48 convolutions.
And the resulting size be 0?
Say it again.
Based on the, now what would be the resulting size of the image?
Oh, yeah, in this example, yeah. Let's make this 3 by 3 convolution. So 3 by 3 convolution will 4 minus 3 plus 1, right? So 2. So yeah, for this small of an input, the third level of convolution layer doesn't make sense. Okay. There's another way to handle it, but if we not worry about the concept, just let's pretend the input image was pretty big so that the size does not get reduced this far, right? So how will the computation look like? So basically there will be a plus over here, just like before, right?
Yeah.
And all the top ones will go over here. So how many additions are going over here?
Total 8.
6.
8 of them.
Right? And then we'll also add the bias over here. We'll pass it through an activation function and then, okay. So even though in this case it doesn't make sense to, further, so this will be, if this was a 3 by 3 convolution, this will be 2 by 2. If we do a sample subsampling, this will just give us 1 by 1 after we do the pooling, right? Anyway, so even though the numbers are so small that we will not use 3 layers of CNN for this particular example, but hopefully you get the idea, right? So if I have a plus over here, this will be adding to all the
last again.
the last one, correct. And there will be 6 additions going on over here. Then
Activation.
the activation function. Then the pooling, and then whatever, right? So how many of these will there be now?
Total 8.
Total 8 over here. Okay, so anyway, before I go further, Michael, does that answer your curiosity?
Yes. Well, sometimes they do a convolution with 1 so that they can keep this side or do some stacking. Can you
Yeah,
explain that?
I'll come to that issue. First, let's get the fundamentals down. Okay. Okay, so anyway, because the sizes don't make sense over here, let me remove the last layer. Okay, so anyway, in our scenario so far, our first layer did 4 feature maps. Our second layer did 6 feature maps, correct? Okay, so now what we do, so let's pretend the purpose of this whole thing was to extract some meaningful, what we call features in our input data. Okay, so what exactly are features? Okay. So let's say we were doing face recognition. Okay, so the way you can understand what this is doing is, okay, the first layer over here, remember as we discussed, convolutions basically enhance the image in a certain way. So the first layer over here is essentially learning some basic curves that form the image. Okay, so all of these are trying to basically come up with some contours that if we put them together, we may be able to reconstruct the face. Okay, as we go to the second convolution layer, now it's trying to put 2 of these together, for example, to form the chin, for example, to form the eye. So purpose of all of this, combining these features, is so that these will be able to understand how low-level features get aggregated together so that they start to form closer to a face, okay? So once we have built these features, then the last part of a CNN is a regular dense network. So, okay, so now what we'll do is we'll flatten this out. So this will get converted to 16 numbers. So whatever the numbers are in the first row will go over here. The numbers in the second row will go below. So there will be basically 16 numbers representing this 4x4 subsampling output. Same way, 16 more over here. Okay, so 16 over here. So how many total we had over here features?
16,
6, right?
Yep.
So 16 times 6 total will be 96 by 1. Everybody agrees? So now these can be fed into a neural network. So suppose the hidden layer over here, we wanted it to be, let's say, 30 neurons. So what will be the size of this W1 matrix?
30 cross 96.
So this will be 30 times 96, correct? Okay, so then we further take these. Okay, and if we are doing digit classification, there will be 10 neurons over here. So what will be the size of this W2 matrix?
10 cross 30.
So 10 cross 30, right? So this is how a CNN, a basic CNN will look like, okay?
How do we know which layer is extracting what feature of the face? So
It's learning from the data, so based on what training data we give, for digits it will be different, for faces it will be different. So that's the beauty of it. It learns from the training data what are the low-level features, what are the high-level features, and puts it together. Okay, so now, like I said, in my opinion, if you want it to be good in any field, right, you have to have a very strong fundamentals, meaning you should be able to create it yourself if you wanted to. So at least one time, I believe you have to program it yourself and make it work. Then the confidence you develop is, then you'll say, oh, I can do anything advanced, okay? Because then after a couple of weeks, I will introduce the TensorFlow library. And as we have discussed many times before, the code to create this in TensorFlow is literally 5 lines of code, okay? But tomorrow, if I ask you, okay, we want to enhance the architecture in a certain way or provide a very specialized loss function, if you didn't understand how exactly it worked, then you can only use the library but not be able to take it to the next level. Okay, so our goal is to be able to do top-notch research in this field. So we want to understand it extremely nicely. Okay, so anyway, now that you have a clear idea of how the layers are being put together, I'll come to the coding part. Okay. In my opinion, 99.99% of the people who are in this field cannot program a CNN by themselves, okay? It's not that because they're dumb, it's because it's very tricky. You guys have already seen even a simple dense layer. If you make a small mistake, you go crazy trying to debug it, right? Imagine now it is a complex architecture. You made one tiny mistake and now you're looking at it for months and it doesn't give you the right answer. So the theory that we develop pretty soon is extremely important. So once you see how it's working, then you'll be able to see how to program it yourself. Further, to help you out, because we don't want to spend too much time, I will give you my implementation of this in C#. I'll explain the whole code. You will take it, and I wrote it exactly the same way, just like we did our last assignment. We had the layer class, we had the network class, right? The difference, as you will see soon here, is, so this part you already know because this is a regular neural network. So this is a regular neural network, right? So we will have a layer class, just like before. We'll have a network class, just like before, okay? But this network now will be consisting of not just regular layers, but also CNN layers, okay? So you will end up adding one more class over here, CNN layer. Okay, and what should go in that class? At first it seems like, oh, this is too complicated, maybe we need to further create a convolution class, a pooling class, and so on, but pretty soon as I show you the whole code that we put it together, you'll see it's pretty straightforward, okay? So one thing we want to do is, just like when we program the regular neural network, okay, if you recall, once we were setting up the network, suppose we wanted 2 layers in our network, right? The regular dense network. How were we feeding it to the constructor of the network class? Anybody remembers?
We were passing all the arguments. We used to create the layers and then we pass it.
We just created a list of layers, right? And we passed it a list.
Yep.
Okay, so now the difference will be, we'll be passing a list of 2 types of layers over here. The regular layer
And the convolution.
and the convolution layer. So as a high level idea, those 2 lists will be passed to the network constructor. Then it will put it together. Okay, the back propagation obviously is pretty complicated over here. But before we go to the back propagation, because unfortunately I'll have to erase this, let's try to at least take a look at, while I have the picture, how will we put it in a completely general way so that we can, once we program it, we can specify, put 3 CNN layers or 5 CNN layers, right? Okay, so what we'll do is we'll create a class representing a feature map. Okay, so if you take a look, let's take a look over here. Let's try to encapsulate all of this part. So all of this box as a feature map class. Okay, so if we do that, then the question is how many convolutions are going on over here? Okay, so remember when we were creating the weight matrix as an example, we needed to know what? We needed to know the number of neurons in the output layer and number of neurons feeding to it, in this case 96, right? Okay, very similarly over here, my question to you is, how many convolutions will this be doing? What does it depend on? Okay,
On how many features it wants in the end.
How many features we want in the end, right? And also, okay, so if we compare, let's say, this part to over here, right? Okay, what you will notice is here, so if I draw this part over here, okay, at first you will say, oh, the size of the array over here, remember it was 6 because we wanted 6 convolutions over here. Okay, but the size of the convolution over here, this k over here, so k will be part of this class, okay, is only 1, right? Okay, so basically, what I ended up doing is I ended up treating, okay, it's been a while I did that code, but I think I ended up creating this as a 2-dimensional array. Because, sorry. Yeah, so see, then what we'll be doing is, okay, we'll be assembling this, all this is one CNN layer. So if we take a look at the whole CNN layer, so let's do this. Okay, now I remember it a little bit. Okay, let's make this up to this part, a feature map class. Okay, so if we take a look at the CNN layer, and if we wanted 6 feature maps over here, you can see internally it will contain 6 of these type of boxes, correct? 6 of these type of boxes. So the difference between, and then if we made this a 2-dimensional array belonging to the CNN layer, so all the convolutions we can make it 2D array. So let's take a look at the size of this 2D array of convolutions. Okay, how many were we doing over here?
6.
24, right?
Yeah.
And you can see that dependent on the number of feature maps in the output divided by number of feature maps in the input. So 4 times 6 was the size of the convolution kernel array that we will need over here, 2-dimensional array over here, right? Very similarly over here. Now suppose this part represents the feature map class because this is really same as here. Okay, but the difference is in this particular case, this seems like a 1D array. This is not a 2D array as we assemble all 4 of these into a CNN layer. But we can treat it like a 2D array because how many convolutions do we have on the output side in this example? 4. How many convolutions we have on the input side or feature maps on the input side? 1. So you can treat it as like a 2D array of size 4 by 1. Okay, so this way we don't have to create a special class for the first layer or the second layer. So once we are able to create a feature map class, assemble it into a CNN layer class, then we can replicate it as many times as we feel like it. Okay, so that's how, and again, once I show you the code, I'll explain it. Hopefully you'll be able to see that makes it extremely symmetric and will lead us to create any size CNN layer in a quick way. Okay, so now let's go talk about the backpropagation and see how will the training of this whole thing will work. Okay, so Sushant, is this part visible?
Yes,
On this side?
of course.
Okay, so now let's take a look at backpropagation for CNN. Okay, suppose we call the output of this A1. Okay, output of this as A2, right? So we can have, again, some kind of a loss function. Could be mean squared error, could be cross entropy, right? So this will be our loss. Okay. Remember when we do backprop, so first let's talk about the forward pass. Okay, if we have proper equations for the forward pass, then it will be easier for us to set up the backpropagation. Okay, so for the forward pass, as you can see, first thing we are doing is doing convolutions with the kernels, right? So let's pretend the first layer. So first layer, let's say we have M convolutions. Okay, so in EG 4. Okay, so if I mathematically express these convolutions, right? So let's take a look at this C1 of 1, C2 of 1, C4 of 1. So would you agree if I have to write Cm of 1, layer 1, Ij, so won't that be equal to as we discussed double summation, let's say u equal to minus 2 to 2. So first let me write it in plain English. So this is basically a convolution of I with a kernel. So kernel would be, let's say, m of 1. Okay, so m will vary 1 to 4. So m varies 1 to 4. Okay, so further we add a bias, b1 of 1. Okay, and then we pass it through an activation function. Everybody agrees? That would be the equation for the first output over here. For example, C1 of 1 or C2 of 1 or C4 of 1. So those will be given by that equation. Okay. So once we have the equation, then we can write it more detail over here. Cm of 1, ij equal to. Okay, for example, this is sigmoid, or let me leave it as f. So this will be u equal to minus 2 to 2, minus 2 to 2, I of I minus j, so I minus u, j minus v, and kernel km of 1 u plus b1 or bm of 1
Question. Why is the summation range from minus 2 to 2?
Because we're assuming a 5 by 5 kernel. So there are only 5 values in this kernel over here. See, it's like, suppose I put 5. Right? Now I start to multiply with the kernel. This is my center value. So you can see from the center, I need to go -1, -2, or +1, +2.
Yeah.
Okay, so that's. Yeah, one of the things, especially as your expertise becomes better in this, is also be able to write the proper math equations so that you can easily express your ideas mathematically. Then converting them to code becomes also pretty easy. Okay. So anyway, so that's the output of the convolution. Now let's go to, what did we call this? If you remember, we call this after we do the pooling, CP1, CP2, and so on, right? So for example, CP of 1, M will vary 1 to 4, is basically pooling on this particular output. So we can now go, okay, and so this will be 0 to 1, 0 to 1, and we can do CM1 of 2i minus u, so u equal to 0, 2j minus v. Okay, and 1/4. So let's say we were doing average pooling. Okay, so later on, if you can draw some numbers over here and convince yourself that this equation, indeed what this equation is doing is adding all of these values, dividing by 4, then going to the next 4 values, adding them, dividing by 4. So that's what this equation is doing. Okay. So with these two equations, okay, and like I said, M will vary from 1 to 4 because in our example, we have 4 of these pools over here, 4 feature maps. So will we know all of these outputs if we apply these equations? Right, straightforward, piece of cake so far. Okay, now let's go to the next layer. In the next layer, as you can see, we were doing many, many convolutions. And let's take a look at now this equation. For example, this will be called C1 of 2. You guys agree? And very similarly, this will be called, before we do the pooling, C6 of 2. So let's try to write the equation for these. Okay, so suppose n varies from 1 to 6. Okay, so then C of n of 2 will be now written as some activation function. Okay, then, okay, now there will be a triple summation, minus 2 to 2, be equal to minus 2 to 2. Okay, and this will go from 0 to 4. Because if you take a look over here, how many things were we adding over here? 4 additions, right? Okay, so we'll go 0 to 4, and the convolution is being done to the previous layer. The previous output, we called it CP, let's say M, and so this will be M equal to 0 to 4, or M equal to 1 to 4, some call it 1 to 4, easy. Okay, so previous output, and I minus U, J minus B, and kernel of UV. Okay, so the kernel will be, now will have 2 subscripts over here. It will have subscript of N and M as an example. 2 plus B of N of 2, and so the whole function. N goes to 6, so this will be, since N goes to 6, this will be Mn. So let's see if you can verify this. Okay, for example, if you take a look over here, so let's pick an example of which one are we doing the convolutions to?
The first one.
So this one is 1, 1, 2, 1, 3, 1, and 1.
Yeah, it's correct.
It's correct, right? Okay.
Professor, can we use CM to not make confusion because we use CM1? Can we use in the second equation CM2? Because I got to, yeah, we
This
use
one?
different notations like CN2. Can we make it CM2? Like,
Yeah, see, the reason I put it C of N is like, I'm trying to match it with this picture, right? In this picture, this was called C1 or C2 or C4. I'm also calling this C1 or C2 or C6 over here. The difference between this and this is at the top, it has 1, meaning layer 1. This is layer 2 over here. So over here, this basically means layer 2. And of course, here, let's say ij equal to. Okay, so now repeat your confusion.
Because for in the above we use CN1, and the second we use CN instead of N. And in the and inside we use N1 to 4. So N1 to 4 for me is the number of inputs, right?
Okay, which equation? This one?
Yeah, CN1.
Right.
And the second one is CN, not N. And we use the N inside. So So
We
just-
use the M inside. Where do you see?
Just on the last equation,
yeah.
and go and the first.
Oh, this one over here. Oh, okay. Let's call it P over here, if that makes you feel a little bit better. P, and then we can call it P. We can call this P. Will that be better? Okay, so anyway, so now we know the equation for up to here, correct? Then what do we have? And of course, you'll repeat this 6 times if you have 6 feature maps.
Why are there 3 sigmas in the
Why are there 3 sigmas? Okay, these 2 are for the convolution, the 2D convolution. Okay, the last sigma, if you take a look over here, is it's adding many of these convolutions, as we had discussed earlier, it's adding 4 of those.
It's adding the features map, right? It's adding the feature. The first signal. The first summation is adding the input feature map.
This basically means the input 1, output 1, input 1, output 2, right? Because there were 6 of them, so this will go K1 through 6. Is that what was your question or no? See over here, as we said, n will go 1 through 6, right? So for example, you pick C1 over here as an example. So now you can see what this will do is, it will pick CP of 1. So first time P will be 1, right? So it's going to do a convolution of this with, as you can see, K1 of 1. So because n is 1 in our example. Do you agree? Okay, then second time through this loop, okay, P will become 2 now, right? So as you can see, what will this do? CP of 2. Okay, from the layer 1, we'll be doing the convolution with K2 of 1. P is 2 now, right? And so on. So if you take a look at this picture over here, it's K1 of 1, it's being convoluted with CP of 1, which is the first part here, right? And if you take a look at this second part over here, K2 of 1 is also being added over here. See, this is being added from here on CP of 2. So you can confirm by going through the picture, pick any example that it's doing